Okay, this lecture is going to be a continuation of solving quadratics. However, we have a homework question here that we're going to go over. So this one is one that's a little tricky with the calculator. And I want to make sure everyone understands when it comes to the test, you're going to have a couple of problems. And we'll talk about this in review, which ones you should focus on. But you're going to have a couple of problems where you need to use the calculator to find the max and the min. Don't do any guessing on those. Don't do trace. Don't use the table. You can use those things to kind of help you figure out an estimate, but you need to use the max min features of the calculator. So what we're going to do is we're going to plug in this function right here, which is 2x cubed minus 3x squared minus 72x. So let's see how to do that. And unfortunately, the camera's following me. Let's see. So I'll do it here. Okay, you guys help me remember. It was 2x cubed minus what? 3x squared minus 72x. Okay, now we're going to, first of all, I do know one of the zeros. 0. That might be helpful for something. But I'm going to hit zoom 6 and watch it come in. Oh, it didn't come in at all. Wait a minute. Let me make sure I filled it in right. 2x cubed minus 3x squared.
There's an x there.
Oh, I knew there was something wrong because, okay. Okay, let's try again. Zoom 6. All right, now watch it come in. We saw it come up, go down, go up again. What does that tell me? That tells me there's a maximum up there, and then there's a minimum down here. Okay, so I might go into my table and see what's going on for these x values to help me change my window. That is one thing that I could do. However, I'm going to try something called zoom fit. Zoom fit is zoom 0, and it works if your x values that are on your window are the ones that are giving you the max and the min. It won't work otherwise. And I actually did one, a student messaged me about the other day. The zoom fit didn't help a whole lot. So I had to just go in there and try different things. And try, you know, in the window, you can change your x max and your x min. And so because I wasn't seeing anything at all, I went way out on x. Okay, like I went out to negative 40 and positive 40 or something like that. And I went way up on the y until I could see the max and the min. But this particular problem, if we do zoom 0, I bet we're going to see more. Okay, so there we go. Now, I'm not going to do the whole thing because we need to get going on the rest of solving quadratics. We got a couple tricky things to work on. So that's it, yeah. Now, this is what I want to make sure everyone understands, though. I don't want any guessing. I don't want you just using the table to figure out what the max and the min are. You got to get it exact as possible. So you got to do your second trace. Oops. Why does it not do that? Second trace. All right, it's not reading my. Let's quit for a second. All right. Sorry, technical difficulties. There we go. Second trace. Come on, thing. All right, so if I want to figure out what that maximum is, I'm going to choose 4. And remember how it works? To the left of a maximum, your function is increasing. To the right, it's decreasing. That's all that matters. So I wouldn't want to go way over here to the right because it's increasing again. So it's not that you have to be close in. It's that on the left of that max, you've got a piece, you're at a place where it's increasing. That'll be your left. So you either tap, tap, tap until you get over there. Or if you know what your x's are, you can just fill it in and get there faster. So you hit enter. It's asking for a right bound. So this is where I don't want to be way over there because it's increasing over there. I need to be on this piece where it's decreasing. So you can tap the right key until you get to the right of the maximum, hit enter. And then when it says guess, hit enter. And then look and see whatever it is that you're supposed to be rounding to. On this one, it's they're whole numbers, so it wouldn't have told us to round probably. Okay? All right. Yes?
Why is my calculator different?
Oh, yours has lines that are actually helping you.
Oh,
Yes, they're showing you where that X is.
Am I supposed to have lines?
No, it's fine. It's fine.
When you
No,
guys
this
were
one's
entering,
just
I'm
more.
like tapping.
Yeah,
It's
this
like backwards.
this is more basic. This calculator's more basic than yours. Yours is a little bit fancier. Okay. All right. Okay, so let's get back to this. All right, now we did the first several problems. I did kind of the review part. We went through that one. Okay. Remember what it means to have a zero. Okay, this is not an equation. Sometimes I have students treating functions as if they're equations. And this is not an equation, it's a function. It tells me how to get an output from a particular input. But it's asking me for the zeros. So what are those? Those are the input values that give me a zero output. Okay? So I do solve an equation. I'm going to make the output, which is f of x, equal 0. And then I'm just going to use my techniques for solving equations to figure out what that is. We're going to use the square root method because we don't have a linear term. We talked about that in the last video. Some students forget to isolate. Remember, you got to isolate. And so we get x squared equals 5. And we're not taking the square root of both sides. We're using something that's true. X squared equals 5. Therefore, x is the square root of 5 or its opposite. And, of course, on paper you can put the plus minus for shorthand.
Yeah, so you have to include the square root. You can't just do plus minus 5.
Right. That wouldn't be right because 5 squared is not 5. Okay? The square root of 5 squared is 5. And the negative square root of 5 squared is 5. Right? Look. Square a negative, you get a positive. Square a square root.
Oh, okay.
Yeah. There you go. Yes?
Can you write it plus or minus?
Yeah, oh yeah, definitely. Definitely. You can't on the online, you have to separate it with a comma. Okay. All right. We're going to take a little commercial break here and talk about something that's going to help us with this next part. There's a lot of pieces to put together to understand what completing the square is. So first off, I want to remind you that if you square a binomial, you get a trinomial. Okay? So what we're going to do together is we're going to review that. So let's take x plus 3 and let's square that. Now, a lot of you have gotten good at doing this without having to use FOIL, but there's still students who struggle with that. So I'm going to rewrite it as x plus 3, so you can see why we get a trinomial. We do not get x squared plus 9. We're going to get 3 terms, not 2. Okay? So multiplying this out using FOIL, we get x squared plus 3x plus 3x plus 9. The outer and the inners are the same. And that's where some students have gotten good at, you don't have to do that, you know what you get. You know, you get x squared, you get twice the product because you're going to have 2 of the same thing, and you do get the plus 9 on the end. Okay? So far, so good? Bless you. So that is called a perfect square trinomial. Now, what we're about to do is we're going to learn a method for solving quadratics where what we do is we turn things into a perfect square trinomial. Why do we do that? Because then we can use the square root method. All right, so suppose that I had, so let me show you where we're headed so you understand what it is we're doing. Because then we're going to learn the technique. And it's pretty simple, but it's important that you understand why we're doing what we're doing, because that'll help you remember the steps. Okay? So, can't reach that high. Okay. We're going to be solving equations like this, where we have a square equals a number. And we're going to solve them. We're not going to multiply this out. Okay, we're learning this technique, and you have to learn it. One of your questions, you will get no credit if you don't complete the square. Okay, if you decide, no, I'd rather use the quadratic formula. Too bad. It doesn't matter if you get it right. Okay, because we're testing that you have learned that this technique. Okay, but we're going to use square root method to solve. So how does square root method work? Well, let's do a simpler problem. We just did one like this. If you had x squared equals 5, x is plus or minus, yes, square root of 5, right? Okay, basically the same thing. It's just that this is not a plain x. It's an x plus 3. So what we're going to do is we're going to say, okay, if x plus 3 squared is 5, then as long as x plus 3 is equal to the square root of 5 or its opposite, this would be a true statement. And then we just have to solve for x. So what do we do to solve for x? Subtract 3. Okay? Which looks like this, or if you put the minus 3 on the end, that's fine. That's not a problem. Just, where's the catch? It seems easy? Good. Okay. The catch is we've got to get our equation in this form. Okay? So now what we're going to do is we're going to... Yeah,
I'm actually contradicting him. I don't understand.
You don't understand this? Okay. So if I have a square equals a number,
Yes, ma'am.
it's easiest to use the square root method to solve it. The square root method is the one that we talked about at the very beginning of the semester, which says if x squared equals a constant, then the thing being squared is either the positive or negative square root of the constant. Now, that works even if you have not just a plain old x squared, but you've got an expression squared.
Okay.
So the inside, you see the inside there, the x plus 3? Since here it's squared, this statement will be true if the x plus 3 comes out to square root of 5.
Okay.
You see it now?
Yes, ma'am.
Okay. And so then we still have to solve it for x. So we subtracted 3 to have it completely solved for x. Here it's solved for x plus 3. Now it's solved for x. Okay, we good on that? All right. So here...
The square root of x plus 3 went away because we used the square root.
Yes, exactly. That's right. That's why it went away. Not because we took the square root of both sides, which tends to cause students to make mistakes. Okay, so here's what we're going to be doing then. We're going to take an expression that's not a perfect square trinomial, and we're going to figure out what we need to add to it in order to make a perfect square trinomial. All right? So let me give you an example. Oh, here we go again. Get my stretching in for the day. All right, so suppose you want to, I'm going to pick one we already know the answer to because we just did this one. Suppose you've got this expression, x squared plus 6x. Here's the question. What number completes the square? In other words, gives a perfect square trinomial. That's what we're talking about. here's how you get it. If you will take, okay, if you've got x squared plus, I'm going to call it b times x. Okay? Take half of b and then square that. Square your answer. You're going backwards. Okay? You're going backwards from what we were observing a few minutes ago. I'm going to write this as an expression because this actually goes on your QEP. It'll say what number completes the square. So you guys can go ahead and fill this one in on that. It's 1/2 b squared. That's what completes the square. So let's do that for this number. But see, you guys already know the answer to this one because we just did it a minute ago. We just saw what we got. Okay? Take half of the 6. That's 3. Now square that. That's 9. So that's the number that if we add to x squared plus 6x, we have created a perfect square trinomial, x plus 3 squared. No, we're not plugging it in. We're adding it on. Now, that may seem weird. I mean, why would you add something on to an expression? But we're going to have an equation. And equations, you can always add a number to one side as long as you add it to the other side. Okay? So now we're going to practice the whole thing. Yes?
Why did you square the 3?
Because it works. Let's just say it that way. Okay? It has to do, if you want to think backwards, it has to do with what just happened here. We're going the opposite direction. We're trying to figure out, that's why, remember this was double. Okay, so we're halving, and then we're squaring, and that's what that number has to be. Okay? All right, so let's take this expression. Solve the following quadratic equation by completing the square. For some reason, this first step is really hard for people to follow correctly. I want to complete the square for the variable part. This thing is doing me no good, but it's an equation. So get it out of the way. Get it on the other side. So we're going to add 10. Sometimes, some of your problems, the number is already over there. But if it's on the left side with your variable expression, and just get it out of your way. Remember, with equations, you're always keeping everything balanced. Everything we do to one side, we do to the other, unless all we're doing is factoring or simplifying. Okay? Okay, now we figure out what number completes the square. So we're going to take half of -6, that is -3, and we're going to square -3, and we get positive 9. Step number 2 should always be positive. Whether this was a positive number or negative, you're squaring, so it should always be positive. Okay? Is everybody following so far? Yeah. Okay. So that's the number that completes the square. So what am I going to do with it? I'm going to add it to both sides. So let's do it in a different color to sort of highlight that. Remember, you've got to keep things balanced. So if I want to add the 9 to this side to create the perfect square trinomial, I've got to add it to the other side as well.
We just add 8, 10, and 9.
And then, yeah, that's the next thing we're going to do. What was your question? Because I'm trying to create a perfect square trinomial in order to use the square root method. Okay? All right, now you're going to write this as a binomial squared. That was the whole point. We were trying to create a perfect square trinomial in order to have a binomial squared. Well, that's the whole point, right? I was trying to make this into...
Oh, you're factoring.
Yeah, except we want to write it as a square. You don't want to have x minus 3, x minus 3.
Okay.
You want to have x minus 3 squared because you're going to use the square root method.
So you take the product, so number 1, or step
That's right. That's right. So this kind of goes backwards with the way you introduce it because it's the 9 that needs to be added, but notice minus 3 is what goes in here. Okay? What don't you get?
How do you go from x squared minus 6x plus 9 to x minus 3?
Exactly. Look. Multiply that out for me. You see what we did? Okay? We had this expression. The reason we added 9 is I wanted this kind of factoring. I wanted the same factor twice, so I can write it as a square.
Okay, so I always just factor FOIL backwards. Well,
If you got, that seems more confusing to me, but okay. So 10 and 9, I already heard you guys saying we need to add the 10 and the 9. That's good. And now we're going to use the square root method. So we're going to say x minus 3 is plus or minus the square root of 19. And then what? Add the 3. And then you're finished. Okay? Yeah.
The answer that we're going to get, say, the 19, would that ever be a perfect square?
It could be.
Where we have to...
Then you would take the square root, like if it had been a 25,
Yeah,
then I would have 3 plus 5, so that's 8, and 3 minus 5, which is negative 2. That's a good question. And that also means it's one that would have factored, so that would have been easier. Anybody else? Yeah.
So we're always going to add after we get the answer for, like, the second part of completed square?
This one?
Or one step out?
Oh, yes. Whatever number you got out of the way, because it wasn't the right number to be a perfect square trinomial, you're adding that same number to both sides, and then you put those together. Simplify. Yeah.
okay.
Yeah.
Back to up there.
Here?
No, on the side.
Here.
No.
Here. Okay.
Yeah.
Okay.
I see the x squared and I see the 9.
Uh-huh.
Where's the negative 6x?
Okay, do FOIL.
The FOIL in the power.
Right? Negative 3x, negative 3x, negative 6x.
You add them together.
Yeah.
So now you have to reverse it, you need to divide it.
Yeah. All right, let's do another one. Oh, and by the way, this doesn't work if I have a number in front of the square. I would need to get it. I would need to divide it. Well, you're probably not going to come across that, but just so you know, you have to have your variable squared without any other constant.
Well, there's one here.
Oh, I don't think we're doing. Yeah. Okay. Now on this one, look. Here's your. See, you've got a square term and a linear term. That's what we want. The number is already on the other side. So I'm ready to complete the square. So I take half of what?
14.
Yes. I'm going to say negative 14. And then we square that. And what did we figure out? We figured out the number that we could add to these two terms to create a perfect square trinomial. That's the number that completes the square. So remember the balance. You're adding 49 to the left. You're adding 49 to the right. Because if you add something to an equation, you've got to add the same thing to the other side. Okay, what's the next step?
You take what's on like the left.
What is it? Yes, x minus 7 squared. That was the whole point. We were trying to write a binomial squared. We created a perfect square trinomial.
Wait, oh no.
You got it?
X, but it's P.
Oh, thank you. Thanks. I do not mind you guys correcting me at all. Okay. And then 40 plus 49. All right. So we created the perfect square. That thing drives me nuts. thing that's following me. Today it's decided to work.
You know, I noticed it's better when it doesn't follow.
I really like it better when it doesn't follow me, but someday I'll figure all this out. Okay, so we've got a square equals a number. Now we're going to use square root method. So we say that the inside, the p minus 7, is equal to the positive or negative square root of the other side. And then one last step, add the 7. And we should check to see if 89 simplifies any, but I don't think it does.
It's like 9.4.
Okay. So we're just going to leave it in. That's called exact value. That is the exact value. Always give exact value simplified unless we tell you how to approximate, and then you can go to your calculator and approximate. Okay, see, that doesn't say complete the square. And, I mean, we could, but then we'd have to work with fractions. We're not going to get that yucky, okay? So we're going to solve this one a different way. So we're looking at a quadratic. Does everybody recognize that it's a quadratic? All right. Because of the square. Okay, the degree is 2. So I don't want to use complete the square. It doesn't tell me I have to, so I'm going to try factoring. So we're going to subtract 3x. This one just isn't a good candidate for that because it's got the 2 in front. Now, like I said, I could divide out 2, and then I could use completing the square method, but you would definitely have fractions that you're dealing with. So that's just not fun. And we want to have fun in algebra. Okay, so we got 1 and 1. This one's not going to factor, is it? Oh, this one doesn't factor. Does everybody recognize that it doesn't factor?
Yes, because of 3.
Right. So we're going to go back and we're going to review how we could find the answers. If all we need are approximations, we can use our graphing calculator. Okay? And we're actually going to use this one as an example for what happens when you use quadratic formula in a little bit. We'll come back to this same problem and solve it using the quadratic formula. But for now, we're just going to use the graphing calculator. So let's go to that. So we're going to be typing in 2x squared minus 3x minus 1. Everybody got that? We're going to hit zoom 6 because remember I was in zoom fit. Okay, and it does cross the x-axis 2 times, so how many zeros are there? 2. And so we're going to use the 0 function, and we will approximate according to whatever the directions say if we were doing this in a homework problem. So remember how you do this is you do second trace, and you're going to choose 0. So that's choice number 2. Now the issue with zeros, which you might have forgotten, is that the function changes sign through the 0. That's how the calculator is working internally. It's got an algorithm that's doing that. So when it asks you for a left bound, okay, here's the 0. I need to be to the left, and the y's are all positive there. So notice there's a positive y. And so I know that one's fine for a left bound. So I'm going to hit enter. But now to make sure I'm to the right, I need to see y change to a negative. It's got to change sign. Y has to change sign from left to right for the 0. This to work. So we're going to do right. Okay, see, that's far enough. I could go further, but that's far enough because I have a negative. What's that? No, this is just my right bound.
Yeah, no, I was just thinking it wasn't right of the vertex, but it doesn't matter because I'm just thinking.
It actually is, but it maybe was hard to see it. Okay? Yeah.
After you put it in, sorry, you push zoom.
No, I didn't. Oh, I hit zoom 6. Zoom 6. Okay, so hit enter. And then when it says guess, you just guess. Okay, so notice y is 0. That means and it says 0. And so we round according to what they said. So let's do, did I say in the directions?
No.
Okay. Let's just do, maybe I wrote it for myself here. Let's see. Because we're going to compare this in a little bit. We're going to do 3 decimals. So you guys go ahead and write down negative 0.281 for one of your answers. And then we're going to find the other one.
So we're finding where it crosses.
Where it crosses the x-axis, that's a 0. You guys ready to find the next one? All right, so second trace, choice 2 for a 0. Now, it actually is to the left of this 0. I could go ahead and hit enter. You guys see why? Here's the other 0 I want to find. To the left of it, the function is below the x-axis. So as long as this is a negative y, it's going to work. I'm going to hit enter. But then I need to get over to the right. Tell me when I can stop. Watch the y. Okay, I can stop because my y turned positive. Enter. Enter. See, that's giving me a 0. Okay? And so the x value is the 0. So that's 1.781.
So what's how did the calculator calculate the 2 different zeros if you're using the same function?
Well, they're 2 different numbers, so I'm not quite sure how to answer your question. There was one over here and there was one over there.
So you just went out left on or right on?
Well, the first one I went to the left and my y was positive, and when I went to the right I had a negative y, and then I hit guess, and it found that one. And then when I was doing the second one, I was already to the left, and it was negative, so I hit enter. But then I tapped on the right cursor here until I got over to the right, and my y turned positive.
All right, so one you look for an x that's negative or y that's positive? And
No. You're looking for all your zeros. There's a 0 right there, and there's another 0 right there. I found them separately.
Yeah. It's just like...
I mean, there could be 5 zeros on a function.
Okay, maybe I'm just overthinking.
I think you're overthinking. Okay, we can talk later, though. All right. Okay, did you guys write those 2 down? Did everybody get those? Okay. Okay. Now, I'm not going to do this whole thing, but I've got some students sitting here who could handle this. All right? I'll get you started, and if you're interested, you can look at where the quadratic formula comes from. But we're not going to go through all the messy algebra together. Okay? But if you're interested, you can kind of work through the rest of it. It's actually something I usually do with an honors module. Yeah.
So the last problem, the solver, we just need to find zeros.
Yes, that's all you had to do, and you could use the calculator on that one. Okay. We are going to compare it to what we find in a minute with the quadratic formula. Okay, so let me just give you an idea of how the quadratic formula comes about, because it's not, something special that came from, heaven and was sent down or something. We actually use the same technique that you guys just learned. It is more complicated because we're doing it in general, leaving A, B, and C looking like variables. Okay? Now, the first thing that happens is we have to get rid of this number in front of the x squared. Now, when you do that, both of these go over the A. So let's just do one more step of the where it comes from. How do we complete the square? We take half of the number in front of x, right? So half of the b over a, which is b over 2a. And then we square that. And so that's b squared over 4a squared. So that is what gets added to both sides. I know it looks weird, but it's just a calculation. It's a calculation that you're actually going to be making when you use the quadratic formula. Now, here's where it starts getting kind of sticky. We got to add the minus c over a. We got to add that to the b squared over 4a squared. So this is where I'm going to depart from subjecting you to the derivation. But what happens, okay, is we end up with a square equals a number, just like we did with completing the square. And we finally get, when we do all the simplification, we get what's called the quadratic formula.
Wow.
Yeah, that's why. See, I don't want to get stuck on that. I want to go to the punchline, which is this.
You didn't have to tell me this.
I just want you to understand where it comes from. Okay? Okay. We're not going to worry about it, but students going into calculus, go do it. Go ahead and work through the steps.
What if you're going into
Okay.
pre-calc?
Yeah, pre-calc. Yeah.
Oh, no.
It's not as bad as I'm making it sound, y'all. All right. But what I want you to understand is this. Just understand this, okay? We start, let's come back in. Okay, we start with a quadratic equation in what's called standard form, which means you're going to have your square term, your linear term, your constant equals 0. That's standard form. And based on what the A, the B, and the C are, through completing the square process, we come up with the quadratic formula that you need to memorize. Okay?
Because there will be problems. You only need that piece instead.
This piece. That's what you need to know. Right here.
I don't need to do anything.
Right.
I do that.
Exactly. You need that.
But why do
Okay?
I feel like I'm going to have to know?
You don't. I just wanted you to understand that it comes from completing the square. Okay? It just that's where it comes from.
Someone who's really good.
Is it too late to kill them now?
Okay. So here you go. Here's the quadratic formula. If you don't learn it correctly, you will miss 8 points on the next test. Okay? So learn it correctly. Make sure you learn it correctly with the symbols, the signs, all the way that they're supposed to be. This is not a plus. It's a minus. Write it down every time you use it, and then probably you will know it. If that's not enough, use a flashcard. If that's not enough, go to YouTube and look up Stickman Sings the Quadratic Formula.
Can we watch that? I want to watch that.
We'll do it after we finish the video. Okay, so we're going to practice using it. Now, does that look familiar?
Yeah.
That's that same one we just found the zeros for. We're going to solve it using the quadratic formula. So we need the 3x on the other side. First thing is you need that standard form. Write down what A, B, and C are, please. Always write them down. At least I can give you a point. Okay? Now, all we're going to do after this is we're going to write down the formula, we're going to plug in those values, and we're going to make the calculation. And ta-da, we have the answers. Okay? What's that? Ah, yes, yes. Okay, so writing it down, please don't be sloppy. The numerator is this entire calculation. That's the entire numerator. Don't be sloppy and not put the fraction bar there. And that is over 2 times the A value. Okay, so now we're going to plug in. Let me make sure everybody's caught up to me. You ready? All right. And I'm going to do every step on at least the first couple. All right? When you start getting good at it, you don't have to do absolutely every step. Like you can go ahead and write down what the opposite of b is. But that's what we're doing is we're taking the opposite of -3. So I'm writing it all down. The opposite of the b value. Plus or minus is shorthand for two separate solutions. That's something you need to understand. Square root of b squared. Now, if you're typing that into your calculator and you leave off the parentheses, you're going to get it wrong because it's the -3 is supposed to be squared. Minus 4 times 2 times -1. I forgot to orient my board. That's a continuous square root there. I can't seem to get it to... Let's start over. Okay. All over 2 times 2. Okay, I'm going to move over here to continue simplifying. So your job is to know the formula, plug in correctly, and then simplify correctly. And the quadratic formula always works. Remember, this was one where it didn't factor. Remember that? If you ever have a quadratic equation that doesn't factor, you can always use the quadratic formula to get the answer. Okay, so we've got 3 plus or minus the square root of 9 plus 8 all over 4, which is 3 plus or minus the square root of 17 over 4. So this one really didn't have a lot of simplifying to do. I just had to make the calculation underneath. Okay, good. Yeah.
How do you differentiate which quadratic formula to use? Is there like a...
There's only one.
Well,
You mean which method to use?
which method?
Okay, the question, so people at home know what was asked, is how do you know which method to use? If it says solve algebraically, if it factors, I would factor it. If it doesn't factor, I would use quadratic formula. If it says you must use completing the square method, use completing the square method. I always have a couple of students who actually prefer it over the quadratic formula. So if it's left up to you, use your preference, okay? You're going to have another problem where I will say use quadratic formula. So use the quadratic formula. If it doesn't say that you have to use an algebraic method, you can use your calculator. Or you can use quadratic formula or factoring if it factors. Yes, ma'am.
So the subtraction sign in front of the 4, does that like go with the 4 like it's negative?
It's subtracting this product. Okay. Does that make sense? So like this one, that product, that's a -1 there. That product was -8. I'm subtracting that so that it becomes +8. Anybody else? Okay, now this is exact value. Let's use our calculators. We'll just do one of them. Okay, there's two answers here, remember. There's 2 plus the square root of 17 over 4, and then there's 3 minus the square root of 17 over 4. So we're going to go to the calculator and see that answer that we just found with using the zero function. So let's do it doesn't matter, let's do the positive one. Okay, now you do have to do order of operations correctly, so you do have to be careful that you have the numerator divided by the 4. So you either use parentheses, like you could say parenthesis 3 plus square root 17. Notice I had to do 2 parentheses because I was closing the square root and I was closing the numerator. divided by 4, enter. Does that answer look familiar?
Oh, and that's the 0.
That's the 0 we found, see? So if I'm taking a quiz at home and I'm practicing the quadratic formula, because that's what I'm supposed to do because I'm trying to get prepared to take a test, then I could go to my 0 function and see if I did it right. You can compare what you found with the quadratic formula to what the calculator gives you. Y'all understand what I'm saying there?
My calculator is letting me do double parentheses. It is coming up as error.
I'll have to look at yours. Yours is fancy. Okay. The other thing, guys, the other thing you can do if you don't want all those parentheses, look, you need to go 3 plus square root 17. I'm going to close that parenthesis. But I've got to press enter because I need the numerator's answer divided by the denominator. Okay? If you don't do the enter, you're only going to be dividing the last thing by the 4. Okay. Yes. No, I'm sorry.
Just put 3 plus 17, square root 17, and then push enter.
Are you trying to do the actual fraction of the 7?
Yeah, and then do divide by 4 instead of putting all of it together.
Okay, I want to address something that was said over here. You asked me if that's simplified. No, that is not what's considered simplified. That's approximate. Okay, there's a difference. Simplified would be like if I had a square root of 20, I need to factor out the 4. Okay, that's simplifying. But this is an approximation of the answer. Okay. Yeah.
Are we going to ask for approximate values on the test?
I might. I mean, sometimes you might be supposed to give the exact answer and sometimes the decimal answer. And I imagine some of the homework is arranged like that. Okay?
Can I use the quadratic formula instead of factors, or should I just do both?
Okay.
I know it depends, but like...
Let me address this question, which is, can I use the quadratic formula instead of factoring? You can always do it. Remember that if you have a perfect... What will happen is, in fact, I've got a lab that we may have time for next week to look at this, but if this is a perfect square, like let's say this was a 25, square root of 25 is 5. Students will sometimes leave 3 plus or minus 5 over the other number. Don't do that. You've got to get your final answer. Okay, you should get the answers you would have gotten with factoring, right? So it wouldn't look like that, 3 plus 5 over 2 or something. Okay, so you have to finish calculating. All right, I want to let you guys practice on the next one, and then we're going to talk about simplification. Yeah.
So the answers, the last problem were the 2 answers we got from the calculator?
They are, and I only did one of them.
Okay,
Yeah,
but yeah.
right. Exactly. I just wanted you to know how you can use your calculator to check your answers.
Mm-hmm.
Yes.
So the quadratic, like change to zeros?
Yes, that's right. Same thing, right? Solutions to an equation are going to be the same thing as the zeros to the related function. Okay? All right, now let's make sure everybody starts out right on this one, but I'm going to give you a few minutes to work this one yourselves. I don't want that x on that side, so what do? Subtract. Good. All right. Now let's get the exact value.
I have a tendency to put in that extra apple.
Oh, yeah. Oh, no, you got to be careful. You need it in descending order so you get your A, your B, and your C correct. Because you mean why did I not write plus 2 minus x? Because you want your descending order so you get your A, your B, and your C correct. Yes, the B is with the X. That's correct.
Yeah, my fault.
Did you get -9?
Yeah.
Did you guys get -9 underneath?
No, I don't
Negative
think
39.
Oh, -39. Okay. I guess I better do my steps, huh? Okay, so -1 squared minus 4 times A. Yeah, -39. Is that what everybody's getting underneath?
Yeah.
Okay, over 10. Okay, and so what did we say last time about when you have a negative under a square root? You always factor out the I. And so this is 1 plus or minus I times square root of 39 all over 11. Is that what y'all got?
Wouldn't it be -1 and then square root 39 and then I?
You had -1, but
No, like the -1 that's under the square root. I meant.
square, that whole thing is equal to I.
Okay.
So it gets replaced with I.
Why'd you make it negative? Why'd you make it 11?
Because I can't read my own writing. Okay. That's a 10, sorry. Thank you. There we go.
So that's exact
Okay.
value?
That's exact value. You wouldn't put an approximation on this one anyway because of the I.
Yeah, because they tried putting it into my calculator and it like came up with weird.
Right. Okay, couple more things. First of all, I want to remember we had complex solutions here. Let's type this one into the calculator real quick and just let me do it because I need to finish up and I want to talk about I've still got a few minutes, right?
Yeah.
Okay. All right, technically. Okay. 5x squared minus x plus 2. I just want y'all to see what this graph looks like. This is what the quadratics lab is about. Now, what do you notice about that parabola? It's opening up. What about crossing the x-axis? It doesn't have any zeros. What kind of a solution did we get? Not real, right? Okay. Now, if I put in that other one that we did a minute ago, the 2x squared, what was it, minus 3x? Minus 3x minus 1. Look at this one. It crossed twice. We got 2 real answers. Okay, remember that? All right, now there's only one other thing that can happen, and I wanted you to notice what the difference was, and this is what that lab is all about, is kind of having you discover all that I'm going through in the next 2 minutes here. But when the b squared minus 4ac was negative, we got no real zeros. We had 2 complex solutions. When the b squared minus 4ac was a positive number, we got 2 zeros. There is one other possibility, and that is, let me see what's next here. Yeah, let me just put this in here. If you have a square root of 0, so you've got, I'm just going to make one up. Say it came out like that, okay? What's the square root of 0? 0. So tell me about plus or minus 0. Same thing, twice, right? What those look like are parabolas where the vertex is sitting on the x-axis. And so that's why you only have 1, 0. And so what you're going to see in the homework, there's a few problems about this. The calculation that's under the square root is what determines the number and type of solutions. This thing has a name. It's called the discriminant. And we're going to fill it in real quick into the notes. Make sure I'm not keeping you guys. Oh, we got 8 minutes. I have enough time. Okay. So we'll come back to this page, but let's go ahead and fill this in. So this is at the end. And then I'll go back to the simplification. If your discriminant, if that calculation is positive, the number of solutions is 2. The type of solutions are real. If it's negative, you get 2 solutions, but they are complex. They will have I. Now, what does that look like if you graph it? What does it look like?
It doesn't pass the x.
Yes, it doesn't cross the x-axis. So you can check yourself, guys. You've got this calculator you can use to check your work. So if it doesn't cross the x-axis, that means there's 2 non-real solutions. If it comes out to 0, you've got 1 real. Okay? And so the only other thing that I wanted to go through was you have to be careful about simplifying. So far we haven't had any simplification to do. Let me let everybody finish that thought right there. We're almost done. Hang in there. 2 more. Give me 2 more minutes. Okay? Let me let everybody finish writing this. So they're going to ask you about that in the homework. They're going to ask you a question that has to do with this. And it's because they're trying to get you to understand what it is that you're finding, okay, and how to check yourself, for example, whether you did your calculations correctly, okay? You ready? Mm-hmm. Okay. Whoop, 1 second.
Yes, sir. Yes, thank you.
Okay. So, a couple of things to simplify. And you had actually, somebody over here had addressed this. If, well, I think this is related to your factoring question, okay? You might come up with something that looks like that if it's one, you're using the quadratic formula, and if this had been a square root of 4, that's 2. Don't leave it like that. That is one that would have factored. It's 4 plus 2 over 6, which is 6 over 6. So you should be writing 1, not this. Or 4 minus 2 over 6, which is 2 over 6, which reduces to 1/3. So that's one. Those are called rational numbers. If you get rational solutions in the quadratic formula, it would have factored. Okay? The other thing is, and you will definitely come across these, so let's make sure everybody understands how to simplify. Maybe we would get an answer like that using the quadratic formula. This is exact, bless you,
Thank you.
but it is not simplified. So we're going to simplify it. Okay? 32 is 16 times 2. Okay? So we're going to think of that as the square root of 16, the square root of 2 all over 8, which is 4 plus or minus 4 square root of 2 over 8. Now, here's the better way to do the simplification there. Be really careful. We talked about this last time. It's both of those over the 8, not just the first one over the 8. So that is 4 over 8 plus or minus 4 square root of 2 over 8, which reduces to a half plus or minus square root of 2 over 2. because 4 goes into itself once and into 8 twice. That's where I'm getting that from. Now I'll let you go. Okay.
Now don't leave.
Have a good weekend. We're graphing next week. Okay.
We need graphing paper?
I will write you what I want you to bring. No, you do not need to go get graphing paper. I've got a graphing handout that you could bring. So.
Can you move the